Well, I'm Tom Brenna. I'm a professor of human nutrition and of chemistry at Cornell University in Ithaca, New York. And I've discussed the essentiality of arachidonic acid from a number of different perspectives, and also have tried to rationalize the recommendations from regulatory groups, or even scientists on regulatory groups, as to whether arachidonic acid should be in formula, and perhaps in a way, in an effort to understand how those statements are made. The first reason I think arachidonic acid should be in infant formulas is because its levels are conserved in breast milks all over the world. And we all recognize that breast milk is the reference food, the gold standard for human infants. The breast milk of a healthy, well-nourished mother produces a healthy, well-nourished baby. Yeah. And so we want to reproduce that composition insofar as possible with ingredients as they are available safely and economically. And we can do that with arachidonic acid. We know that. So we're discussing whether it ought to be in formula or ought to not be in formula. Well, okay, so it's in breast milk. This is not some sort of strange compound. This is not a structure that I would identify as a pesticide or some other kind of thing that we see in breast milk if we look carefully. So it's not some sort of a thing that we theoretically identify as being superfluous or something we wouldn't add. We'd never add pesticides to baby formula intentionally, just because they're found in breast milk. Okay. Arachidonic acid is at very high concentration in the brain of newborn infants. It actually, as a net, increases over time. In other words, the percentage decreases, but the net amount of arachidonic acid increases, and it increases quite dramatically. Arachidonic acid is a precursor. It is made into another fatty acid called adrenic acid, and that is found at substantial concentrations, not as high as arachidonic, but substantial concentration in all normal brains. And we know less about how adrenic works, but we know it's there. And all of it comes from arachidonic. So it isn't just a matter of how much arachidonic is there, it's also a matter of supporting this other thing that we know is there. Another component of this question of whether arachidonic is required is the interplay between the omega-3s and the omega-6s. So most of us believe that DHA, omega-3 DHA, is required for optimal infant development. I think that's a relatively non-controversial statement, certainly in preterm infants. I don't think anybody disagrees with it there. There's still a little argument that won't go away, but I think for average term infants, the same is the case. And so in part, we're talking about the interplay between omega-3 and omega-6. Now, most people have some sense that they are competitive in a way, and so that imbalances between the two can lead to harm. Certainly that's something we've speculated about over the past years in adults. Well, this is a different story. Now, this is not chronic disease. This is not the development of heart disease, but this is the development of the brain, and arachidonic, it's the development of lots of other stuff, because arachidonic has all sorts of functions that really were recognized a decade or two before DHA's functions were really understood. And so the net effect of a recommendation to add DHA and not to add arachidonic is to really push an imbalance that we don't really know, unleashed on a population of infants, of millions of infants, how that's going to play out. Certainly a formula like that would be different than any feed that would come through the breast. There's no breast milk like that. That does not exist, a breast milk like that. So that's the only way you can get something like that is to formulate it that way. So most of us working in these fields over the years recognize a balance between these two, a balance between DHA and arachidonic. And so in that sense, it really is an essential fatty acid because it's connected to DHA. DHA is an essential fatty acid. I can expand a little bit on that concept as well. The research over the last 30 years, I think that's a fair number, has been primarily directed to the development of functions that are, I like to call them DHA-centric, meaning functions that are connected to neurology, the brain, and to vision, the retina particularly, where DHA has been known for, well, since the 1960s to be sky high, and since the 1970s has been known to be key to the function of those organs. And so the majority of the data that we have on the essentiality of these long-chain polyunsaturates, DHA and ARA and arachidonic acid, are based on outcomes like visual response, like cognitive ability, and the development of cognitive ability that are chosen based on DHA. They're not chosen based on arachidonic acid. And the vast majority of the data that we have, furthermore, uses both of them, uses both DHA and arachidonic acid. So if I ask myself, what is the standard of care for a developing human infant from newborn to at least 6 months of life, but well beyond that, we recommend exclusive breastfeeding up to 6 months, but many choose to go to 2 years, and that's great. And I've known women that go to 4 years. Depends on the kid. Had a graduate student with a 4-year-old nursing daughter, as I recall. Anyway, the thing to consider is, what is the standard of care? Mm-hmm. So the standard of care, is it breast milk? We all recognize breast milk as the best thing for the baby. Or do we consider a standard of care to be a older formula, which was often called conventional formula, that has no long-chain fatty acids at all, no DHA, no arachidonic acid? And I am afraid that the field developed along the lines where it considered these long-chain fatty acid-free formulas as the standard of care, and compared a formula. It was always called supplemented, and I don't like the word supplemented in this context. So we wouldn't say that formula is supplemented with vitamin C. No, we would say it is a component of formula, and the reason it's a component of formula is because there's vitamin C at some level in breast milk. There's all the nutrients in breast milk, so that's how you make it up. So you don't say, well, I'm supplementing it with that. It's just a component. But they're comparing two formulas, one that has no DHA or arachidonic acid to a formula that has DHA and arachidonic acid. And then looking at outcomes. Well, I think of it a different way. I think the gold standard, the reference, should be breast milk. And that's what we should be aiming at. And we can do studies of composition that with great precision and accuracy because they're chemical analyses. And they're not asking medical questions about biology and physiology. They're simple compositional questions. So we understand these things very, very well. And we know that arachidonic acid is in all breast milks worldwide. We know DHA is in all breast milks worldwide. So the burden of proof, it seems to me, in formulating an infant formula that deletes a nutrient that's in all breast milk worldwide, is to look carefully at all the things that that nutrient is known to do and say, well, maybe, and to show that it does not matter whether that nutrient is there or not. Okay, so we are nowhere near anything like that. We have, to the best of my knowledge, 3 studies of a formula with DHA and arachidonic acid compared to a formula with only DHA. And in those studies, we've looked at DHA-centric outcomes. And even with those 3, one of them is significantly better with the arachidonic acid, and that's a vision study. Even with only 3 of them. And in fact, one of them I normally discount, and I think most people in the field discount it because the DHA level was so low as to be, we would consider it deficient today. It was done in the 90s. And so I actually think the weight of evidence, even taken from that perspective, favors arachidonic acid. Prudence favors the addition of arachidonic acid, not the deletion of it.
Sure.